So we're going to talk about verifying trig identities, which can be a little tricky or triggy, but okay, verifying trig identities. Here's what it looks like. You're given some statement that looks like this, and you have to show why. And why means that you fill in all the details to prove the equality. Now I can hear what you're saying. Oh, but why do we have to do this? So as you move into higher math classes, you need to get more creative with problem solving. And being creative in math can be very hard. So we start now with trig identities. You're going to see that not all problem solving is just follow these steps and then you magically get the answer. Sometimes you have to just really think and pull kind of tricks out of a toolbox that you have. And so in this case with trig identities, we actually have a toolbox. It is the identities that we know so far. So you can pause the video to write any of these down. I would recommend having all of these together on a sheet. So we've got the reciprocal identities, the quotient identities, the Pythagorean identities, and then the even-odd identities. So these are going to be what I use to verify our identities. And so as I go through, I'm just going to show you a bunch of examples in this video, along with some strategies to help verify identities. So let's start with the first strategy. The first strategy would be just to rewrite the more complicated side, i.e. work from one side. So the directions for all of these will be to verify, and I'll show you how. So I've got 1 minus sine squared x over cosine x equals cosine x. Okay, so notice that this side looks more complicated, right? So this is where we want to start. And okay, the thing I notice here is that on top, this reminds me of the Pythagorean identity. So as far as how do you actually prove something like this? So you're going to have to give yourself plenty of space. What I would do is I would probably rewrite some of this 1 minus sine squared x over cosine x. So make sure you just have plenty of space for this. And so here I can kind of call out that I want to use my Pythagorean identity, but I want to state that I'm rearranging it. So notice normally it would be sine squared theta plus cosine squared theta equals 1. And the way that I want to think about it, I'll just show you. I want to rethink of this as cosine squared theta equals 1 minus sine squared theta. Okay? So just on the side here, I'm going to write that out. Cosine squared x equals 1 minus sine squared x. So you need to make sure that you're filling in details in a way that's neat and clear. And so then I can rewrite this top part as cosine squared x over cosine x equals cosine x. And then I can just kind of put a note here that I want to cancel out a cosine x term, or factor. I guess factor would be more proper. So this makes it very clear, you know, kind of how I got here. Kind of what you need to do when you're writing up your work. You need to find some way to clearly write this out. And so maybe you want to just have like a quick sentence, but you need to state what it is that you're using. And the reason why you want to do this neatly and clearly is that it's going to help organize your brain when you're going through this. And it might actually help you, like when they start getting really hard, this can also help you to just figure out like maybe why something didn't work when you use that much detail. Okay, so next problem, I'm actually going to suggest that already, right, we just learned this, but I would recommend that you try this one on your own. Pause for a second, look at the identities that you have, and see if you can figure out how you can work the more complicated side to verify this one. Try to write it out and then hit play when you're ready. Okay, so when I think through my identities, one thing that I know is that with the Pythagorean identities, I have sine squared theta and cosine squared theta. When those two are combined, I get 1. So I can actually rearrange this so that my sine squared x and my cosine squared x are together. So I have sine squared x plus cosine squared x plus tangent squared x equals secant squared x. And now what I'm going to do is I'm actually going to make a little call out box here and note, so this is a Pythagorean identity So this equals 1. And so then I get 1 plus tangent squared x equals secant squared x. And hey, isn't that just another Pythagorean identity? So once again, now I just want to write maybe on the side here also a Pythagorean identity. Okay, so there we go. So that's one way that you can just work on one side and then you end up kind of falling into equality like we see here. Strategy 2 is try to express the functions in terms of all sine and cosine. So let's take a look at some examples here. So I've got it. Tangent x over secant x equals sine x. So a lot of times when you can write things in terms of sine and cosine, things will cancel out. So I want to show you one other thing with this too. Consider breaking up that fraction into two fractions like you see here. So I haven't really done anything. I just rewrote the problem. And then I can write each of these. So tangent is sine x over cosine x. And then secant x is 1 over cosine of x. And so now I can just flip this, right? So so 1 over secant x, this is actually also a reciprocal identity. So it kind of goes both ways. So if I have secant theta is 1 over cosine theta, then it also holds that cosine of theta will be equal to 1 over secant theta. So these are reciprocals of one another. That's like something that you get out of the reciprocal identities. So anyways, however you want to think about that is up to you. But now I can rewrite this as sine x over cosine x times cosine x equals sine x. And now you can see why these cancel out. So in this case, I was able to really just kind of use algebra and to kind of neatly organize that. I didn't even necessarily have to call out one of the identities because it was like more clear in the work. So you have to kind of use your own best judgment in how to clearly show your work. So moving on to B here, why don't you try this one on your own? Again, you've got a good hint here. And I'll give you one other hint. You should be able to solve this, but this is the more complicated side. So working on this complicated side, try hitting pause, work your way through it, see if you can figure out how to verify this, hit play when you're ready. Okay, so when I think about this, I know that secant x is the same as 1 over cosine x. So now if I were to distribute here, when I distribute, I get sine of x over cosine x, and then I get cosine x over cosine x. So I'm trying to prove that this equals this. Now, of course, this goes to 1, and this is equal to tangent of x. So then I've got tangent of x plus 1 equals 1 plus tangent of x. And so now we have shown and verified that these are equal to one another. And so I used, just to remind you, quotient identity, tangent of theta is equal to sine of theta over cosine of theta. So that's what I used to help me get through this one. Okay, so now let's move on to strategy 3. So factor or complete indicated algebraic operations. So before we get too far into this, I do want to help you just see kind of how to factor certain things. So let's think back to good old algebra for a second. Just x squared minus 4. How do you factor something like this? Okay, x squared minus 4. I mean, if you're in trig by now, I hope you know how to factor this. X minus 2, x plus 2. So that's one of like your standard algebra ones, right? Now, the thing is, I think a lot of trig students can factor this. This is really the same as this previous one, but I'm going to tell you a little hack if you ever look at this. So if you have sine squared x minus 4, if this starts to throw you off, you can just pretend for a second that this is y squared, where y is equal to sine. So if I asked you how do you factor y squared minus 4, well, that's literally what we were just doing, right? Y minus 2, y plus 2. But now where there's that y, I can replace it with a sine. So this whole thing will factor as sine x minus 2 and sine x plus 2. Now, maybe you looked at that and you said, oh, that makes total sense. I wouldn't need to use this trick. sometimes trig is going to mess with your brain, and so knowing how to use these tricks to get your brain to kind of figure it out is very important. So I have 2 more of these here. So I would challenge you to pause the video here, see if you can factor these, and hit play if you're stuck or if you think you've got it. So the thing to notice with this is something squared and this is something squared. This is still a difference of squares. This is no different than these previous 2 that we were working on. So again, if it's messing with your brain, sorry about that, if it's messing with your brain, let's call this for a second, let's call this a squared. And then let's call this one b squared. How do you factor a squared minus b squared? Well, you know that would be a minus b, a plus b. But what's in my a position now? In the a position is all of tangent x plus cotangent x. Okay, so I've got to give myself a bunch of room here. Tangent x plus cotangent x. So that was what a was. And what's in the b position? So I'm doing a minus b, right? In the b position is this tangent x minus cotangent x. So look at how I've got this set up. Tangent x minus cotangent x. So that is this first factor here. Are you seeing that? And then for the other one, a plus b. So now I'm going to take this plus this. So let's see. I'm running out of a little space here. So let me just erase a little to give myself some space. Okay, so we had, the first one was tangent x plus cotangent x, and then I subtracted off tangent x minus cotangent x. Okay, that was the first part. Now we do the a plus b. So now I think I've got to really write these in 2 pieces. Tangent x plus cotangent x, and then tangent x minus cotangent x. Now, you might say to yourself, oh, but now I can simplify the inside. That's fine. Now let's simplify the inside. So if I were to simplify what I see here, I am left with really this first piece here. So notice what happens. The tangent x's drop out, and I'm left with cotangent, and then you've got the negative and the negative, so this really becomes cotangent plus cotangent, right? So that's 2 cotangent x. And then what about here? So here, I see that let's see if I go here, my cotangents cancel out, right? And then I'm just left with tangent plus tangent. So that becomes 2 tangent x. And so remember, as a reciprocal identity, tangent is sine over cosine and cotangent is cosine over sine. So if you multiply these things together, they actually cancel out with one another. So I'm running out of space here, so you can write out the work if you don't believe me. But these end up canceling out, so you're just left with 2 times 2, so this actually just equals 4. That would be the whole value. And then what about this last one? 2 sine squared x plus 3 sine x plus 1. So again, this is something you should be able to factor. It's not a difference of squares, but you can try that hack that I've been talking about if you haven't tried this yet. Okay, so let's replace all of these signs with a y. If this is messing with your brain, you can rewrite this as 2y squared plus 3y plus 1. And that I can factor, let's see, as 2y plus y, and then let's see, plus 1 plus 1. So does that give me what I need? This gives me 2y squared. This will give me 2y plus 1y, which is 3y, and then we've got the 1y. So yep, that works. So here's how that factors, but now where I see the y's, I'm going to replace this with sine. Do you see what I mean by that trick now? So this is how you can kind of trick your brain if you're looking at this and you're going, I don't think I can factor this. Okay, so I wanted to discuss that because now we're going to go back to verifying. So starting with this first one, so I want you to work on just factoring just this side, okay? Just this side for now. Hit play when you think you've factored it. So the left side will factor as sine squared x minus cosine squared x times sine squared x plus cosine squared x. So I've got all of that. And this is going to equal 2 sine squared x minus 1. So you can see how everything kind of works out. Okay, so now this is where you want to pause and think for a second. Do you see any trig identities here? Yes, we do. So remember, sine squared x plus cosine squared x, that is one of our Pythagorean identities, right? So I can rewrite, I'm going to go ahead and just kind of highlight this. This part here, this equals 1. So this is a Pythagorean identity. Okay, so now I'm left with sine squared x minus cosine squared x, just this, I don't even need the parentheses anymore. This equals 2 sine squared x minus 1. Okay, so now we have to think through how else can we rewrite this. Well, again, if I go back to my Pythagorean identity, so I could solve this Pythagorean identity for cosine squared x, or for cosine squared theta. Okay, so I've got, let's see, let me get back to this. So this part here, I'm going to use cosine squared x equals 1 minus sine squared x. So you want to just kind of call out somewhere what you're using. So I've got sine squared x now minus 1 minus sine squared x. So is that going to equal the other side? Yes, it will, right? Because now I've got sine squared x minus 1 and then minus sine squared x. So this will turn into a positive, right? So this gives me sine squared x minus 1 plus sine squared x, and now we're there. So I've got 2 sine squared x minus 1 equals 2 sine squared x minus 1. Boom, done. Okay, so moving on to B here. So remember, part of this strategy was to complete your algebraic operations. So in this case, you're actually being asked to multiply this part out. So I would recommend that you try to multiply this out. So remember, you've got to do this times itself. It's not just cotangent squared minus cosecant squared. You need to write out cotangent x minus cosecant x times cotangent x minus cosecant x. Okay, so you have to multiply this out. I would say pause here, give this a try, hit play when you're ready. Okay, so let me see if I can give myself enough space here. So let's see. Just focusing on this side, and this becomes cotangent squared x minus 2 cotangent x cosecant x plus cosecant squared x. Okay, so now I'm not really totally sure where to go from here. So I know that I can write all of this in terms of sine and cosine. So let's just go ahead and do that and see what we get, and then see if we get inspired. So, okay, this is going to be cosine squared x over sine squared x. This one will be, so 2 cosine x over sine x times 1 over sine x, and then this will be 1 over sine squared x. Okay, so thinking forward with this a little bit, so notice that if I multiply these together, this whole side has a common denominator, right? So this will become 1 minus cosine x, 1 plus cosine x. So just to make this nice and clear, I'm going to write this all out for you guys. So this becomes minus cosine x over sine squared x, and then plus 1 sine squared x. So keeping with the spirit of just like getting through your basic algebraic operations, if you have a common denominator, then you probably just want to try to add everything together. So I need a little more space here. Okay, so now I'm going to just put everything over the same denominator. So I have cosine squared x minus 2 cosine x plus 1, all of this over sine squared x. Okay, so now what? Well, this sure feels like it can be factored, right? And this is why we did all those factoring exercises, because this can kind of pop up whenever. So I can factor this side. So again, like remember, you can convert these to like y squared minus 2y plus 1 if your brain is not seeing that, just to kind of convince yourself. This top part here is going to factor as cosine x minus 1 times cosine x minus 1, all of this over sine squared x. So now what? I've gone as far as I can with my algebraic operations, right? And now I'm left with this sine squared x. So now what do you think of? This is where you go back through and now you look through your identities. Nothing here, nothing here. Oh, hey, right, sine squared is mentioned here, and this has something to do with cosine, right? So I could rewrite sine squared x is equal to 1 minus cosine squared x. And so that's exactly what I'm going to do here. So I'm going to just put a little note so that I know what I did. So I'm going to use the Pythagorean identity. And so now I've got 1 minus cosine x over 1 plus cosine x, cosine x minus 1, cosine x minus 1. And so then let's see, this becomes 1 minus cosine squared x. All right, anything else you see? Now this is technically a difference of squares, right? You could think of this as 1 minus y squared, right? That would factor as 1 minus y, 1 plus y. You believe that? Make sure you believe that. Okay, so I need more space again. And I'm going to factor. So I've got 1 minus cosine x over 1 plus cosine x, cosine x minus 1, cosine x minus 1, and then 1 minus cosine x, and 1 plus cosine x. All right, so now we have a little bit of a problem here in that I have cosine x minus 1 and 1 minus cosine x. These are not the same thing, right? So they're in the wrong order. So how do you deal with that? So when your stuff is in the wrong order, an option that you can take is, so if I have cosine x minus 1, if I factor negative 1 out of that, I can flip the order. You see how I did that? So that's what I'm going to do. I'm going to rewrite this first term here like this so that I can flip my order so I can make some cancellations. So let me do that now. I've got 1 minus cosine x over 1 plus cosine x. Factor out the negative 1 so I can flip the order here. And now I've got this. Oh, we're so close. Okay, so now those cancel out. Cool. So now I'm left with 1 minus cosine x over 1 plus cosine x. And I've got this negative 1 times cosine x minus 1 over 1 plus cosine x. We're so close. So now if I were to distribute this in, when I distribute this in, I can now reverse the order. So just a little more space. So if you're not fully understanding what I'm talking about with that negative 1 trick that I just did, I'll show you it in reverse now. So like I said, I'm going to distribute this in. So if I distribute this in, so let's just go in pieces here. This becomes negative cosine x plus 1. And so then if I just wanted the 1 to come first, this would become 1 minus cosine x. Ta-da! Ooh, that one required some work, huh? All right, we're still not done. This is kind of a long video, sorry. Okay, so strategy 4. So far I've just been manipulating one side. Sometimes to get the job done, you gotta manipulate both sides. So starting with example A here. So what do you think that we need to do to each side? Well, on the left side, it looks like we could probably make our lives a little bit easier if we spend some time maybe just rewriting everything in terms of sine and cosine. So remember with our reciprocal identities, so I just want to point out that I've got this like 1 over secant x and this 1 over cosecant. So remember, we've talked about this. So these are reciprocal identities, and then kind of buried with that is also cosine of theta would equal 1 over secant theta, or sine of theta would equal 1 over cosecant theta. So let's take a second to just rewrite these in. So I've got cosine of x, and I've got 1 over secant x, and then I've got sine of x times 1 over cosecant x, and this is secant squared x minus tangent squared x. Okay, so now I can rewrite this as cosine x times, well, this would really just be cosine x, right? And then this would be sine of x times sine of x. I haven't started manipulating the other side. I do like to go just kind of one at a time, but now I've got cosine squared x plus sine squared x equals secant squared x minus tangent squared x. Okay, and so now if I refer to my Pythagorean identities, I know secant, or the sine squared plus cosine squared is equal to 1, right? So now I have basically shown that this side equals 1. It's a Pythagorean identity. And what about the other side? So I've got secant squared x minus tangent squared x. Well, that's also a Pythagorean identity, right? So if I were to subtract tangent squared x, I would get that this whole thing equals 1. So actually that's what the other side equals. So this side also equals 1, also with a Pythagorean identity. I'll just write ID. So actually I have 1 equals 1. So now I've shown that the two sides are indeed equivalent, and I had to work on both sides to do that. Okay, so let's try this next one. So I've got tangent squared sine squared x equals tangent squared plus cosine squared x minus 1. Okay, so I can see by looking at these that I probably want to get maybe everything in terms of like just cosines or something like that. So I'm just kind of thinking off the cuff here because I'm not sure how to do this one. I'm doing this one and just thinking out loud. I feel like this sine squared, I would like to play around with this Pythagorean identity and rewrite it as 1 minus cosine squared just to see kind of what I get. So this is kind of like some of the experimenting that could happen. So I get tangent squared x. This becomes 1 minus cosine squared x. I haven't done anything to this side yet. Okay, so if I were to distribute this, now I get tangent squared x minus tangent squared x cosine squared x, and that all equals this side. Now, you might be tempted, something that you shouldn't do, you might be tempted to try to cross these sides. So I might say, oh, I'm going to take minus tangent squared x and minus tangent squared x. I wouldn't recommend that you do that. You want to try to manipulate one side, keep this side to itself and manipulate it, and then keep this side to itself. When you start crossing over the two sides, I think you make it very easy to make a mistake and to lose something. So try to keep everything contained to one side. Okay, so next, I feel like I can probably cancel some stuff out here. So you can see now that that can definitely be done, right? So this is tangent squared x plus cosine squared x minus 1. So the cosines will drop out. And so now I have tangent squared x minus sine squared x equals tangent squared x plus cosine squared x minus 1. Okay, so there's several different ways that you could do this, and I just want to show you like a one way. You may be looking at this and think, oh, I could have done this a different way, and it's totally true. But remember, the philosophy here was that I wanted to work on both sides. So what I'm going to do, just to show you how I can make both sides kind of match, let's say now that I leave the left side alone and I decide to rewrite this as -1 minus cosine squared x. Why would I do that? Well, if I factor -1 out, that flips the order of this, right? And then this would become sine squared x. Now, did I have to do it like this? No. So remember, there's not like one way that you could go about these. You might have said, oh, I would just use a Pythagorean identity here, and that would still be fine. So it's whatever you see. But sometimes when you're not seeing something, you might want to play around on both sides. But anyways, so I'm running out of space here, but I think you can see how we have our equality. I'd probably put one more line just to show that I've got the two sides matching now, but I'm going to skip it just in the interest of time. Okay, strategy 5, use the conjugate. So this is, first maybe we should just talk about what is the conjugate. The conjugate is found by literally just taking the sign in between two terms and flipping it. So if I have x minus 4, the conjugate would be x plus 4. If I have square root of 2 minus square root of 3, the conjugate would be square root of 2 plus square root of 3. If I have sine x plus 1, the conjugate would be sine x minus 1. So it doesn't matter, by the way, if I wanted to make this, just to drive the example home, what if there was a negative here? What if this is negative sine x plus 1? This would still be negative sine x minus 1. It's just the symbol in between that you want to flip, okay? All right, so that being said, let's just verify one more. Okay, so I've got 1 minus cosine x over 1 plus cosine x equals cosecant squared minus 2 cosecant x cotangent x plus cotangent squared x. Okay. So I like this one because it looks very similar to something we were doing earlier. So what I'm going to do is I'm just going to show you this trick now, focusing on this side. So I've got 1 minus cosine x over 1 plus cosine x. And so I'm going to manipulate this expression by multiplying by the conjugate of the denominator. So let's just see what happens if I multiply by 1 minus cosine x on top and on bottom. So let's just see what happens. So I'm going to multiply the top out. So this becomes 1 minus 2 cosine x plus cosine squared x. And the denominator will become 1 minus cosine squared x. Okay, so like I said, this is pretty similar to something we were looking at earlier. And my challenge to you is, can you now continue to manipulate this so that you end up making it equal this? You're going to have to think through some of your identities. I think this is a really good challenge at this point. To pause, try this. Even if you get stuck, that's totally fine. You will understand this so much better if you take a moment to really do your best with this and then look at the answer. Okay, so this part here, I can go ahead and rewrite this as sine squared x. Okay, so obviously I'm going to need some more room, so let's make some space. Okay, so let's go ahead now and rewrite this. So this equals 1 minus 2 cosine x plus cosine squared x, all of this over sine squared x. And now I want to break this up into separate fractions, okay? This becomes 1 over sine squared x minus 2 cosine x over sine squared x plus cosine squared x over sine squared x. Okay, so notice now this is cotangent squared x, and this is cosecant squared x. So we've almost got the identity that we were trying to prove, right? So the last part then is this fraction here. I need to break this up into two pieces. So let me show you. So now I've got cosecant squared x minus 2 cosine x over sine x times 1 over sine x plus cotangent squared x. Okay, and so now you can see this part here is cotangent x, and this part here is cosecant x, and that was exactly what we were looking for, right? So then let me clear space. So now I've shown that I've got cosecant squared x minus 2 cotangent x cosecant x plus cotangent squared x. And that was ultimately what I was trying to prove, right? I think maybe I flipped the order of these two, but otherwise I've got it. And so we did a really similar problem to this, but now we had a very different result and a different way to get there. So like I said, there's more than one way to kind of attack some of these. So I have one more example video of just a few more verifying trig identities if you just want to see some more examples. So feel free to check that out. And otherwise, that brings us to the end of this one, guys. I'll catch you in the next video.